Welcome to the Deep Dive, your essential shortcut to understanding the complex shifts happening right now. Today, we're diving deep into, well, a really interesting intersection. We're looking at AI agents and the foundational and, let's be honest, often frustrating world of data engineering.
That's right. And if you work anywhere near data, you know the struggle intimately. Our source material really confirms what so many engineers feel every day. Data teams are just spending an overwhelming amount of time wrangling data, patching broken pipelines, just managing endless maintenance.
All that technical debt.
Yeah.
It just prevents them from delivering the strategic insights the business actually, needs.
It's a huge problem.
And it feels like a systemic issue, one that's born from complexity. I mean, the sheer difficulty is in how siloed all our data is today.
Oh, absolutely. We're talking about petabytes of information scattered all over the place.
Right, different clouds, you've got legacy operational systems, various data lakes, hundreds of custom APIs.
And each one with its own structure, its own security layer, its own access constraints. It's a logistical nightmare, really. It just eats up budgets and time.
So it's not just a technical problem, it's a complexity multiplier.
That's a perfect way to put it. The sheer volume of components, all the custom scripts, the scheduled jobs, the transformation logic, all of it has to work in perfect sync.
Across all those different places.
Yes. And that requires constant manual human oversight.
But, okay, the promise here is what's so revolutionary. We're starting to see the rise of these specialized AI systems, what we're calling Agentic AI. And they're built specifically for data integration.
And we should be clear, these aren't just LLMs that write text.
No.
They're systems designed to reason, to plan, and to actually execute tasks autonomously using tools. It offers a real path out of this maintenance cycle.
It feels like a fundamental paradigm shift.
It is. It promises to transform data engineering from, a reactive maintenance job into an accelerated capability that actually fuels strategy and innovation.
Okay, let's unpack this then, but let's feel the pain first. For our listener who is constantly putting out fires, what exactly makes today's traditional data pipelines so rigid and so tedious? Why is that maintenance such a crippling time sink?
Well, the rigidity is it's inherent in the design. Every time a data engineer builds a pipeline today, they're using what's essentially an imperative approach. They're telling the system exactly what steps to take.
Step by step.
Step by step. Fetch data from X, run this stored procedure Y, apply script Z, and then load it into target A. That means they're relying on this fragile mix of ETL tools, custom code.
Python, SQL, that kind of thing.
Exactly, and fixed schedules.
Wow, so that sounds incredibly brittle. One little change and the whole thing just collapses.
It is. The moment any source system changes, a tiny update, a new regulatory field, or even just a simple column rename, the entire chain just breaks.
Yeah.
Our sources gave a really relatable example of this. That single schema change can trigger hours, sometimes even days, of painful debugging and retesting.
I remember reading that. One team lost 3 full days tracing a single deprecated API call because it wasn't documented correctly. That's the kind of inefficiency we're talking about. But it's not just the hours lost, is it? It's the opportunity cost.
Exactly. When, 70 or 80% of a data team's bandwidth is just consumed by chasing these repetitive fixes, making sure the old pipes still flow, they have no time left.
There's no time for the new stuff.
None. They can't integrate that new customer behavior stream or build the sophisticated features that differentiate the business. They're just trapped in a cycle of technical debt.
Always prioritizing patches over progress. It makes the solution feel even more urgent. So if maintenance is this monster consuming all the human effort, the agent has to be incredibly intelligent to slay it. Let's look at the toolkit. What specialized intelligence do these agents have?
Okay, so the agent's brain, you could say, operates using a triad of deep understanding. It needs 3 core areas of intelligence to function independently.
Okay, lay out the first pillar for us.
The first is robust source comprehension. And this is revolutionary because the agents are designed to understand all the data sources in your system at scale.
All of them.
All of them. This includes structured relational data, totally unstructured data, like complex documents, images, and dynamic data coming from APIs. And crucially, they understand this regardless of where it lives.
So across different clouds or like lockdown on-premise systems?
Yes. They have a generalized intelligence across the entire data landscape.
So they're not biased towards one type of architecture. They see the whole data supply chain as this single navigable map. But what about the meaning of that data, the quality?
That leads directly to the second pillar, contextual awareness. This goes way beyond just understanding the data structure. The agents understand the technical metadata.
Like data types, sizes, that kind of thing.
Right, but also the entity relationships and, most importantly, the business semantics behind the data.
Can you give us a quick example of a semantic issue, something that would trip up a traditional system but not an agent?
Sure, think about the difference between a zero value, a null value, and a field that contains NA. A standard SQL join might treat all three differently, and that would lead to faulty analytics.
Right, I've seen that happen.
A sophisticated agent, though, using its contextual awareness, can grasp that in the sales table, a null might mean data is missing. But in the inventory table, a zero might mean out of stock.
So it understands the operational meaning.
It understands the meaning and can apply the correct transformation or cleansing rule automatically. It prevents those pesky data quality issues before they even start.
That level of sophistication is what moves us past simple scripting. And the third capability is about turning that intelligence into reality, right?
Precisely. The third key area is pipeline creation and optimization. So the agent doesn't just suggest steps. It handles the full complexity of building an executable data pipeline.
So multiple joins, conditional logic, all the business schools.
All of it. Everything needed to prepare that data for its target use.
And once the pipeline is designed, the agent figures out how to actually move the data in the most efficient way.
Absolutely. Underlying all this, the agents automatically figure out and select the best mechanism to deliver the data. They'll assess if the target needs real-time updates and then choose streaming, or if a large batch load is better for ELT, or if replication is needed.
They're not just building the pipe, they're optimizing the delivery strategy.
That's it.
That decision-making power is a huge leverage point. And I think the sources noted that these agents can fit into the existing engineering workflow.
Yes, they integrate seamlessly. Data engineers don't have to learn some new proprietary language. The agents can accept requests directly via standard channels, like ticketing systems.
Like Jira or something.
Exactly. And they determine which specific target systems, whether it's a data warehouse, a BI dashboard, whatever, to feed the newly transformed data to.
Okay, so we've established what they do. Let's pivot and get a bit more technical. This is a deep dive after all, so let's look under the hood. For our listener, what are the mechanics powering these systems? How do they translate a natural language request like, I need weekly regional sales totals joined with marketing spend from last quarter into a functional pipeline?
What's really fascinating here is how multiple advanced AI technologies are sort of synthesized to achieve this. Agentic systems start with large language models.
Right, LLMs, we hear about them constantly, but how do they function here specifically? I mean, beyond just writing an email.
Here, the LLMs are used as the intent engine. They parse the messy natural language requests from users and translate those, ambiguous requests into a structured logical sequence of steps. They're the initial planner.
So the LLM translates the intent into a blueprint. But a good engineer doesn't just build a blueprint once, they optimize it. How does the agent learn and get better?
That vital layer of continuous optimization is handled by reinforcement learning, or RL. RL is used so agents can constantly refine and improve their execution plans over time. And crucially, the system learns by observing the real-world outcomes of its pipeline runs.
Can you give us a specific example? What constitutes a reward in this engineering context?
Well, it's defined by key engineering metrics. A successful run that completes quickly, uses minimal cloud compute, and achieves a high data quality score gets rewarded highly.
Okay.
So an agent might initially plan a full batch job, but if RL sees that past, similar requests were successfully done using a much cheaper, lower latency streaming method, it learns. It learns to prioritize the streamed solution next time.
So it's essentially optimizing for the data team's budget and their speed goals automatically.
That's it. It learns the most cost-effective, high-quality path.
That makes the learning process extremely relevant to the bottom line. But the critical distinction you mentioned earlier, and that the sources stress, is that these agents don't just generate text. They actually perform actions in the real world. They move and transform data.
Exactly. And this capacity for action is handled through a mechanism known as tool calling.
Tool calling.
Tool calling lets the agent step outside the generative model and interact with the real technical environment. This is how they use the applications and external systems they need to connect to data sources, query metadata, and carry out the transformations. They're not generating poetry, they are generating executable code.
API calls, SQL statements, platform commands, the things that make the data actually move.
Right.
So bringing all those pieces together, the LLM parsing intent, RL optimizing the plan, and tool calling executing the action. You get a system that completely bypasses all that manual hand-coded ETL work.
It's the full automation of the entire data orchestration layer. It dramatically reduces the cognitive load and the time to insight.
Okay, that sounds almost too good to be true. If the agent is doing all this complex work, does this create a black box problem? I mean, how does a human engineer audit this and make sure it hasn't introduced some hidden logic that's going to cause problems?
That's a really important question, and the sources are clear that auditability and explainability are crucial. These systems have to be built to output clear, auditable logs and often a human-readable summary of the plan and the logic it generated.
So the engineer moves from writing the code to approving the plan.
Yes, approving and auditing. They maintain control and oversight without getting bogged down in the minutia of implementation.
That addresses a key concern. So what does this all mean for the engineers and analysts who will actually use this? Let's look at the practical examples. What are the immediate, tangible use cases we can expect?
We can break the practical value down into three major categories. The first one is declarative pipeline authoring. So instead of writing complicated step-by-step scripts, engineers or analysts simply describe the outcome they want in natural language. The agent takes that declaration and builds the full optimized pipeline.
That moves the engineer's focus entirely from how to build the pipe to what the business needs from the data, which that shift in focus directly enables the second major use case, which is a game changer for speed: business user self-service.
This is a massive acceleration point. Business users, analysts, the people closest to the decision-making can now request or even create new data sets themselves using simple language.
And that doesn't just save time, it improves accuracy, right?
Right.
Because the request isn't lost in translation through 3 layers of technical handoff.
Exactly. You get a much faster time to insight.
And the third practical application is arguably the most crucial for reliability: data quality and observability.
This is where the proactive nature of the agent really shines. They provide continuous reliability. They act as this hyper-vigilant watchdog using automated lineage tracking to monitor the source environment.
So they can detect subtle changes, like a column-type mismatch or a schema drift.
And they can proactively propose or even apply a fix before the job fails. They prevent downstream issues entirely.
They present the fire rather than just putting it out.
Precisely. They handle continuous monitoring for anomalies. They automatically trigger backfills to fix historical data gaps. And they can even reroute data around temporarily failed sources to ensure the data delivered stays trustworthy.
Okay, so if we systematically summarize the value here, we see clear benefits for 3 distinct groups. First, for the engineers.
For data engineers, it's a liberation of resources. Less time on repetitive, low-value fixes, and more time for complex integration challenges, strategic architecture, and creating brand new data products that really move the needle.
And then secondly, the business users who rely on the data.
For them, it's accelerated access to reliable data. It speeds up their decision-making, it eliminates those long waiting periods, and it ensures they are working with the freshest information available.
And finally, the AI systems themselves benefit from this.
Absolutely. The agents ensure the data flowing into analytic systems and machine learning models is cleaner, fresher, and prepared with much greater accuracy. And as we know, AI systems are only as good as the data they consume. Agents are building better data supply chains at scale.
It's clear that these agents intelligently solve the endemic problems in data integration by helping to plan, monitor, and adapt to data challenges in real time.
The transformation is fundamental. Data integration is shifting from this fragile, custom-coded patchwork of jobs to an adaptive, goal-driven process that's ready to support the next generation of AI and business intelligence.
That adaptive quality is the key takeaway. As these AI agents mature and take over all the repetitive manual fixes, they're going to free up a tremendous amount of human effort in every organization. And this raises an important question for you, the listener. If your data engineers spend less time connecting pipes and more time strategizing, what brand new capabilities or complex integration challenges will your organization be prepared to tackle next? What are the strategic projects you've been putting off that you can now finally address?
And critically, you have to consider how this shift fundamentally redefines the required skill set for a data team moving forward. The focus shifts entirely from being highly proficient in coding maintenance to being an expert in system architecture, governance, and really business strategy.